This is Eric Hess with the Encrypted Economy. And on this week, we had Dan Bogdanov returning to the podcast. Dan is the head of R&D at Cybernetica, a professor at the University of Tartu, and the co-inventor of Sharemine, a secure, privacy-enhancing technology platform. So we started to move in this episode into privacy-enhancing technologies, and we cover homomorphic encryption, multi-party computation, zero-knowledge proofs, functional encryption, FPGA, or programmable integrated circuits, federated learning, neural networks, and digital identity. We also talk about Sharemind, Cybernetica's secure computing data analysis platform. I led off this second episode by asking him how privacy-enhancing technologies could change the ability of businesses to outsource functions that previously they would not have due to their highly proprietary nature. If you haven't listened to my earlier episode with Dan, Estonia, the Rise of a Digital Nation, I encourage you to do so. And of course, if you enjoy this episode, I encourage you to share it with others. And with that, I bring you my second episode with Dan Bogdanov on privacy tech, data, and nuclear waste. Welcome to the Encrypted Economy, a weekly podcast featuring discussions exploring the business, laws, regulation, security, and technologies relating to digital assets and data. I am Eric Hess, founder of Hess Legal Counsel. I've spent decades representing regulated exchanges, broker-dealers, investment advisors, and all manner of fintech companies for all things touching electronic trading with a focus on new and developing technologies.
Some of these technologies are very suitable for outsourcing, meaning like put workflows on the cloud. Homomorphic is very good for that because assuming that you want to use a single cloud provider, then you just stuff everything onto your cloud of choice, homomorphically encrypted, and then they run all the workflows using homomorphic encryption and all is good. Multi-party computation requires multiple non-colluding parties, meaning that putting everything on a single cloud is sort of counterproductive. You're making the cloud a trusted third party. And that means that there are outsourcing technologies which are very good for outsourcing, like homomorphic and encryption. And then I would argue that trusted execution environments are also pretty good for outsourcing. And then there are these partnership technologies where you have distributed control. Whereas if you put stuff on the cloud, then you sort of assume that the cloud has certain control or they can run stuff on your behalf. In these consensus requiring technologies like MPC, people need to have hands-on for things to run, meaning that your partners are symmetrically dependent on you and you're dependent on them. Unless you all agree that you will run this, then you can't run this. And that's a whole separate type of technologies. It's if you try to do partnership things with homomorphic encryption, then you run into a situation where somebody is still more king than the others. You can emulate it on trusted execution by using specific architectures like remote attestation and so on. Like we do that with Sharemind, where you just before any calculation can start, then everybody remotely attests and receives a proof that this is the algorithm we're running. It's sort of middle ground. There's still one party who is running everything, but they can't run anything without everybody else saying, yes, I fully agree to what's being done. In the future, maybe homomorphic encryption will also gain similar capabilities. Functional encryption is something that has been designed for that purpose, but they're not fully integrated yet.
Are you talking about like ZKP, Starks, Snarks, bulletproofs?
No, the things you mentioned in that list was mostly all zero-knowledge proofs. And we're also working quite a bit on zero-knowledge proofs. We are performing research in this DARPA zero-knowledge program that's currently ongoing, where we are focusing especially on e-government and sort of private-public interactions and using zero-knowledge in interactions between governments and citizens and companies. So, for example, currently we are building a system that would allow you to pull in your health records from healthcare providers, digitally signed, and then prove in zero knowledge to, think of it like maybe the military recruiter, that your health records correspond to a certain standard. They won't know exactly what's in your health records, but they know that this proof was put together from digitally signed health reports from these valid healthcare providers. And the whole sort of a flow of trust is preserved by using zero-knowledge proofs. And that is, again, an interesting model we see that supports a distributed data architecture for a government or a large corporation, that you're pulling data in from multiple sources, data about yourself, and then you're making a proof about this data. Instead of just passing this data on for someone to read in the clear, you're actually constructing a statement which says that I had this data, it was signed, I ran this code on it, calculating the results of this algorithm that was standardized. Maybe you provided me with that algorithm. And here are the results of that algorithm. The verifying party looks at the results and says that, okay, understood. Yes, this is irrefutable evidence that you have calculated this result from this data, and because it was digitally signed and I also have a zero-knowledge proof of the signatures, then I have to assume that based on information from these sources, this is true. And again, this is going to create interesting new transactions between participants in a digital society that we hope will be there in future versions of the Estonian government or other governments in the world.
And when you were talking about functional encryption, what were you talking about specifically?
Functional encryption is a specific cryptographic construct that you can use, again, that you can calculate a certain function. You can give somebody data and then they can run a certain function on it. And there are limitations on what they can calculate. It's basically limited to that. That's sort of a very oversimplified version of it. But the thing is that mathematics is giving us a lot of primitives, full homomorphic encryption, multi-party computation, all of these things, and converting them into real-world platforms that you can just go and use on your device is something that takes hard work. And one thing that I am very thankful for is that the crypto asset and cryptocurrency community has given us a lot of very good research on MPC, threshold encryption, and also blockchain technologies, and hashing, things like that. This has been something that pushes the world forward. And these days, if you're a cryptographer and you are doing zero-knowledge proofs or cryptographic research, then there are a number of startups in the fintech or payments domains that are willing to hire you. And you can go in and you can do researchy things, I would say. Yeah, obviously, it's assumed that at the end of the day, you will be building a service, you will be building something, but people understand that the technology isn't there yet. And for some interesting reason, venture capital is willing to put money into things which I would argue is still in the R&D stage.
And I think that's going to continue. I mean, particularly with some of the AML KYC verification that is now becoming, I guess, FATF and governments are requiring more AML up front. It even impacts decentralized exchanges. And so in a decentralized exchange, basically it's very lightweight. So how do you ensure that these checks are being performed while still facilitating the transaction in a lightweight way with a fully decentralized exchange that's basically just code without people running around? So I think for cryptographers, the field is only growing because this issue of how to actually leverage personal information, maybe secure multi-party, maybe through zero-knowledge proofs, whitelisting and checking identities, but in a way that doesn't slow down the transaction, in a way that doesn't allow a DEX, which is lightweight, to now have to take on both the obligations of a compliance department. And now that you've taken in this data, now you also have privacy concerns. So you've taken in AML and you're like, great, I've done AML. No. Now you have all these privacy regulations that you have to comply with because you took this data in. So it's poison, right? Like, it's the last thing you want. It's not one regulatory regime. You've just inherited two, and probably there's a few more that come from that. Like, now you're just going back to a fully centralized organization. So the pressure to find lightweight solutions to facilitate this has just increased. And cryptography is central to that, figuring out ways to both remain on the public blockchain, but yet privately share this information in a way that's trusted, that doesn't slow down the transaction. So exciting times for cryptographers.
The lightweight issue is going to be pretty much key, because a lot of the constructs are pretty heavy when it comes to math and processing needs. And obviously, all the chip makers are going around and opening champagnes, because every time chip makers, what's the incentive for chip makers to make stuff faster? Not everybody is playing computer games on top of their new fancy graphics card, right? So in order to just run, even to run this call, I don't need a very big investment in equipment. It's running on top of a MacBook Air, which is not the fattest laptop in town. So the question is, how do you keep selling cool, new, powerful chips? So you need to add new features, and security is indeed one of them. So building all kinds of cryptography and security technologies, privacy technologies into hardware is going to be an interesting direction. And we already see how Intel has gone this way with SGX, AMD with SCV, and this is being embraced by cloud providers, Microsoft with a lot of its confidential computing work. Also IBM Cloud provides SGX boxes, and it's a developing field for sure, also in hardware. And now the question is, with software, if it's open source or you have the source code, you can easily go and audit. The hardware question is always going to be, can you trust the hardware? Because nobody's capable of going down into a 5 nanometer process and then reverse engineering it. Not nobody, but it's very expensive and not fully accessible to everyone. So trusted hardware is going to be interesting as well. Whether a chip that promises it is doing accelerated fully homomorphic encryption is doing that, or it's also on the side not doing it, so or doing something else, trying to analyze it in some way. That's an interesting question that hardware makers will need to answer in the future, because putting these technologies from research papers, fundamental research, to the field is a significant undertaking. So the math we needed for building our X-Road and Sharemind and these smart ID systems, it was there. We had to develop the math a little bit, massage it into protocols. But when we had to go and build real world systems around it with all the economic considerations, deployment architectures, fraud detection, obviously, as well, just as you mentioned, is going to be interesting. Well, regarding the fraud and the regulation things, I do like whoever came up with the thing that data is not the new oil, it's the new nuclear waste. You want to get rid of it at some point. If you used it, then at some point after that, you need to get rid of it somehow because it becomes toxic. So very much agreed with what you said there as well.
It's been a while since I've considered the hardware integration. Used to work a lot with Wall Street firms and developing, quant trading algorithms. And, years ago, there were, people were building chips with integrated algorithms built into the chips. Part of the problem, of course, is you got to be pretty sure you want to stick with that algorithm because it's hard to change. And then a number of years ago, patented system for modularizing components of the chip so that you could actually modify the hardware on a modular basis. There's this whole research paper I read, and if I even tried to do it justice, I read it. I understood it conceptually, but I could never explain it. So, but it was really about, I just remember it was like magnetic polarities, and that's the way you would modularize the chip, be able to change the magnetic polarities to sort of, change, it wasn't like fully, it didn't give you a whiteboard to start again, but you could basically take existing code and through different magnetic components, change the, modularize the functions.
That could be interesting one day if maybe all programming comes down to neural networks, just setting the parameters for the neural network. That the chip is just a big neural network, and you just set the weights and set the layers, and that might be something where this works. But if you're doing hardware, then obviously there's a trade-off of how quickly you want to go on the market and how many units you want to build, because you can get FPGAs programmed pretty quickly, but they're not as performant as ASICs, and ASICs might not be as performant as fully cooked circuits on transistors and so on. So there is the economic aspect to everything cryptographic. And this is one thing that I currently also see is a lot of cryptography gets a lifeline, although economically, I'm not sure it will survive. And that's something where venture capital also is creating an interesting situation, and where the quantitative easing and the availability of money on the global market is creating a situation where it's not sure that all the technologies we currently have and all the coins and tokens systems are going to be sustainable in the long run. But we are learning so much about them for now. And this might inspire something that we will actually build and need in the future. So I'm very excited about all of that work. So trying to keep our eyes open at all times.
So we've talked a bit about a few things. We haven't talked about Sharemind, your project. You've noted it, but let's dig into it a little bit. What are the technical aspects of Sharemind that differentiates it from other end-to-end encryption?
So think of it like this. Secure channels on the internet between you and your online bank, they ensure that you cannot, that nobody can listen into your discussion with the bank. If you send them a transaction that you would like executed, then you will put it on the channel and the bank will receive it. And there's a pretty good level of trust that nobody has changed the transaction and nobody has eavesdropped on it. Sharemind tries to do the same thing with analytics. The data owners put encrypted data in on one end, and on the other end, there is an analyst who gets the results out. And the whole process from the beginning to the end is under encryption. That's the simplest way. That's what we want to do. We want to do end-to-end encryption for data processing and analytics. And Sharemind is considered as an application server, which runs your business logic or queries with the data still under protection, meaning that even if you are the host of a Sharemind server, then you do not have access to the data. It's even worse, you can't do everything you want with that data because, as I mentioned previously, either using hardware attestation or multi-party computation, the consensus protocols, you are restricted from doing anything you want with that data. And once you've gone through the processing as directed by the algorithms that have been deployed on your on your instance of Sharemind, then you disclose the result to someone who has the keys or the ability to reconstruct the result. So that is the core idea. And what we believe this to be useful for is all kinds of data-driven services that want to operate in a way where they don't have to be trusted by all their users. So imagine that you want to start something new. You want to pull together something that nobody has done before. You want to get all the health records about all the people. You want to run an AI model on it. You maybe want to find people who are at risk of a certain disease. But the model doesn't work for you in that way that you can go to every person and say, hey, this is my algorithm, please run my algorithm. It's not like the common model where you have a check, it's sort of a self-check. I go in, put my data in, and then I get the result out whether I have a risk or not. If you're a government these days, then you would like all this knowledge, these algorithms to be run on everybody's data so you could intervene before diseases get more complicated, before they get more expensive to treat, for example. And for that, you suddenly get the need that you need to pull together and integrate and link databases, which not everybody might be comfortable with doing, especially if you're doing like population scale things. And Sharemind is a solution for that use case, among other things. Then there's also other kinds of analytical projects. For example, one thing we did in Estonia with the local tax data and education data was we set up a Sharemind instance where information was put by the tax office on students who had enrolled in IT curricula and in non-IT curricula over a number of years. And at the same time, into the same Sharemind instance, data came from the Ministry of Education about their studies at the university. The idea was that, can we understand what's the sort of a return of investment on IT studies? Do the IT students actually graduate in time? What do they do with this? So, and are they in some way different from the non-IT students, maybe who went to study sociology or languages or biology and physics, something like that? And what we achieved was that we were able to have two agencies with their distributed silos encrypt the data on site, put it into a shared environment where only the statistics that had been agreed to would be run, and the statistical output was provided, which was the report on students' graduation behaviors and earnings and things like that. And at no point was anybody able to look at the confidential tax records or the somewhat less confidential education records. So it's a sort of dream of linking data together and analyzing it and learning the insights without having to worry too much about privacy. And also last year, 2020, where there was a landmark case from the Court of Justice of the European Union, which is sort of like, let's say it's the highest court there is in Europe. And it was about the data transfers between the EU and US. It was, yes, it again had to do with Max Schrems and his work on upholding the GDPR actually with big American tech companies. So the decision, which pretty much said that the European American data transfer regime is not sufficient for actual protection. So you have to figure out something else if you want to continue transferring data from Europe to the US. And that created a mayhem in health research and in various domains which had relied on previous legal regimes for working across the Atlantic Ocean between American and European partnerships. And obviously, very quickly after that, the agencies of data protection in Europe and all the other people started coming up with solutions. And actually, multi-party computation has been proposed as a technology for cross-border collaboration by one of the agencies. I believe it was the European Data Protection Board or the European Data Protection Supervisor. One of their statements from November 2020 actually suggested that multi-party computation would be such a way. So again, this is something that's pushing the technology adoption forward. Because again, we've tested MPC, we've tested Sharemind running in Europe and US data centers, like across the Atlantic, MPC being done. This worked, and it didn't even cost an arm and a leg. So that was nice as well. So we certainly see that Sharemind will have a part in the future of building systems for AML, anti-money laundering information sharing. We are working on that with some partners. On cybersecurity threat intelligence. Cybernetica also has an R&D collaboration with the Air Force Research Laboratory in the United States on building a cybersecurity threat intelligence exchange network between Estonia and the US. That is a very interesting project, and consider that if we pull that off, then there's little things we can't pull off, because getting defense organizations to exchange data across borders, even among allies, as we're both NATO members, it's still a challenge. So might be that we are able to really, really improve partnerships of nations and countries using technology.
So I use that as a template.
Yes, exactly. Create blueprints. And that's something where the goal is with Sharemind. I've also been interested in doing health research, could be improved using this sort of technology. But what we also see, and that's actually now about MPC on the broad market. So Sharemind is an MPC system designed for analytics. It has a pre-built library for running regressions, certain machine learning algorithms, and so on and so on. You can put it into mobile apps, web apps, all of that. It's a pretty good system. Now, who else is doing MPC these days? Facebook has their own MPC framework. You can find it, I think, also it's open source. Google has their join and compute system. Apple has their MPC system, which they plan to roll out this fall in iOS 15. That's the somewhat controversial child sexual assault material countering system, which was supposed to scan iCloud photos and then compare the hashes to a known list of illegitimate material using secure computing, like MPC-like techniques. So MPC technologies are being embraced by large companies these days. We haven't even talked about federated learning, which is deployed in every Android phone. So I would say that the maturity level of privacy technologies is quickly growing. Not every application will need Sharemind. Some of them will go for set intersection. Some will go for homomorphic. Some will pick something which we haven't even heard about yet. The paper is coming next month, maybe. But the point is that going for technologies that allow you to trust your service provider less is, I believe, a next step in the maturity model. It's not fully against the cloud providers as well. I'm totally certain that the big cloud providers of today are able to provide a more secure server experience than something running in your broom closet or in some of the local small-scale data centers, which don't have all the same levels of control because of economies of scale. And at the same time, so cloud used to be the thing that you scared people with, oh, it's not secure, but that's not the point really. Cloud can also embrace these technologies and they can offer them for you. And many have, as we mentioned before, with the Microsoft and IBM clouds, and I believe AWS heading in that direction, and Ali Cloud as well. So I do firmly believe that in time we will be able to have end-to-end secure analytics workflows. And with Sharemind, we are trying to create one technology which is battle tested. It's been deployed on multiple clouds across the ocean by governments and companies. And this is our contribution to that ongoing development.
And you mentioned federated learning. Do SMPC applications these days or frameworks have that federated learning integration component to them?
No, not really. Federated learning is still a totally different idea, whereas MPC technologies assume that the data is sort of put into the protocol. All the data is put into the protocol, unless you have a specific application. Then federated learning is a form of machine learning which allows you to keep a lot of the data on premises at different sites, and then you do a certain amount of local processing, and then you go to a central node, and then you do a certain level of aggregation there. You put together the next layer, next version of a shared model, and then you go back. And then you continue processing on site, and then you again come together in the center, and then you put together a shared model, and you go back and you do this iteratively, so that you don't put all the data, all the eggs in the same basket ever. So I believe Android phones use it for keyboard prediction, machine learning for keyboard prediction, and that's actually rolled out on billions of devices. So if you're looking for a good example of a privacy technique being widely deployed, then that's that. And obviously, the other great example is the contact tracing exposure notification system that Android and Google rolled out for COVID-19, which also allows you to do processing of data without having anywhere a central super database of who has COVID and who hasn't. So it's a really elegant design. Parts of it come from EPFL, a university in Switzerland, but it has been modified by Apple and Google engineers. And it was also a great show of collaboration and standardization, because Apple and Google phones are able to do this interoperatively. meaning that Apple phones can alert Google phones and vice versa, which is not always the case for, things like iMessage wasn't instantly available on Android phones or so on. So that was a great show off, again, partnership in a way.
And what would be an example where an organization might use an SMPC framework together with a federated learning framework?
You can actually combine them rather interesting ways. MPC frameworks can be the core of the federating learning frameworks, and that allows you to do some additional privacy tricks on this federated learning model. So there is this thing called differential privacy, a technique which allows you to add statistical noise to the outputs of a query in order for a potential attacker not to be able to understand what the input data was. Because sometimes by looking at the outputs, you can have a bit of an idea what the inputs were. But differential privacy makes that a lot harder. So federated learning techniques, the common ones, they do still leak the model. And sometimes machine learning models leak information about the input data. So that you combine federated learning with MPC, then you might be able to use differential privacy-like techniques to throw in some noise and make sure that the machine learning models you're building, they don't have clearly encoded input patterns in them. So for example, if you overfit a machine learning model, it might actually contain one of your input data records as a sort of an example. So because machine learning tries to cover every input it has, and in the worst cases, it just says, okay, so 99% of the data I can fit with this model. And then the 1% of the data which I was forced to include, but it doesn't fit into this nice big model, I just keep it here as this was an exception, and I'm just keeping it here. I will say yes to this, but that also means that it's sort of encoded in the machine learning model, one input record. And that might be leakage if it's encoded in that model. And if that was private data, then you might land in hot water by having such a model. So combining federated learning with multi-party computation allows you to add potential extra features, privacy features to your machine learning models.
And so as you're building out Sharemind, I guess you have a fully functional product, but where do you take the product from here? Like, what do you see as the future for Sharemind?
The future for Sharemind is that we need integrations. We need to make it easy to use, because today we provide SDKs. We provide some ready-made tools already, so you can get a statistical environment up and running very quickly. But we understand full well that potential users of Sharemind might want to contain some of their existing environments. They might want to keep on using the interfaces they currently have. So integrating Sharemind into business intelligence systems, query systems, statistical systems, some way, which you use to collaborate. Maybe there should be a Sharemind version of, Doodle or a survey system. We actually have built a survey system on top of Sharemind, which can run on the cloud as a publicly available commodity service. It's doable. And that's, I think, where we need to go. We need to build solutions. We've got the technology. Now we need to go and start targeting individual business lines, individual solutions built on top of it. And then we will get to really wide scale rollouts.
Right. We had Kurt Roloff from Duality Technologies on the podcast a while back, and his comment was, he goes, my mission, is to make homomorphic encryption boring. And what he really meant was ubiquitous. And where he said, I don't want people to be talking about whether it's homomorphically encrypted or secure multi-party or not in a few years. It'll just be something that, of course it was. That was obvious. Why wouldn't we do it?
Yes.
Exactly. That definitely stuck with me.
Kurt's a good friend, and when he was developing homomorphic encryption years ago, then I was doing multi-party computation in the same DARPA program. So we've actually, had a lot of these discussions together, and I'm very happy for all the success that he's been having. And there's many others with whom we've been doing this, because a lot of people working on secure computing believe that this is actually how informations are supposed to be. and I am one of them. The principle behind there is pretty simple. That okay, this might get a little bit philosophical, but consider this: computers. We have data protection regulations because we designed computers wrong in the beginning. Computers were designed not to protect data, but to copy data. And that was logical, because why would you want a computer? Because what do you do with it alone? The power of computers really blew up when you had them networked, when you could copy data from one to the other. So then they really flourished, the whole idea of computers, by getting data exchange and ease of copying. But the problem is that computers make copying data so easy that there is no control. If I send you a file, then you can put it on the internet, you can put it on whatever, dark web, BitTorrent, wherever. You can print it out in 1 million copies and throw it around from a helicopter. And computer made it possible to make copying as easy. What if we had built computers so that copying was somehow better controlled, but still possible? This is what I think we're doing with fully homomorphic, secure multi-party computation. We're building the next generation of computers, which gives you better control over how data is copied. And maybe we won't need privacy regulation in the future. That's the sort of, we'll need it for some other things like ethics. We still need to figure out ethics so that you wouldn't build totally unethical things. But a computer built on these technologies might actually solve a lot of data protection. We might be able to throw away 3/4 of the GDPR if that becomes ubiquitous. So fully agree with Kurt here. We're sharing the same dream. I would like the world to be like that as well. So even once we've built these computers of the future, which are programmable with rules of what they can disclose, then humans will still be needed to figure out what the disclosure rules are. Because again, the guy in the utilities company will need to know which address they need to send the water to in my house, and so on, and the electricity. So there's multiple layers of security needed, and this is going to be one that I'm hoping will crack open a lot of the exchanges and joint processing and analytics in a way that we don't have to ask so much of the privacy questions anymore. The ethics issues still remain, and I'm adamant on repeating that. I mentioned the AI and e-governance project. We did a machine learning model on houses and fire emergencies. Can we predict which houses catch fire using a machine learning model? Then we could go and try to do interventions, maybe go in and ensure that these people have their fire alarms, that they have batteries in these fire alarms, and so on and so on. And the question is then, but can you go on some people's personal homes and ask them, we are afraid that your house will catch fire soon. This sounds like a racket. This sounds like, right, exactly. So we have reason to believe that your building might be in danger of fire. Which is are you going to light it on fire? Is this Fahrenheit 451 or what is it now? So there's a sort of this whole, even if you have great machine learning models, can you really do interventions? You might not be able to do interventions. And then the question is, do you get the economic effect? Obviously, a person can go and I would like to do a self-check for my building. What's my fire risk score? But how many people do opt in these days? Not many. You have to do campaigns. You have to get them, catch them on Facebook or something. Then you have to get them to consent, and then they do all of this. So the question, a big one, and I don't know how to solve this, is, and possibly it can't be solved, maybe it shouldn't be solved, is exactly how you do interventions on this machine learning thing on a grand scale. Because again, I do believe that in certain places, this should be done in order to help people catch diseases that they might be in danger of contracting in a few years, or something they have in their genomes will tell that they will catch cancer in 5 years. It just hasn't come out yet. We'd like to proactively help you with that.
I mean, that's intriguing. So certainly from a health perspective, I think if you come to somebody and you say, we have information that suggests that you might have these health issues, if you think about the channel, possibly people might be more inclined to believe you if you can kind of support the fact that you have credibility. When it comes to things like their housing or their security, I think it gets a little harder.
Another thing Cybernetica recently did with the government is we helped design a consent service for secondary use of data. The government has a lot of data on people, and it's pretty good quality, like on average. So the question is, could other services use the data that the government has on me? And maybe the government built a consent service, which is like, I don't know, a Open ID Connect kind of a login thing. But I go and use a startup service, and the startup says, okay, before I give you your, report, I would like to access your tax records. And I will now forward you to the governmental consent service where you will give consent, and then I will receive the tax records and I will give you your credit score. Looks nice. The question is exactly that, does consent solve everything? And yes, consent is nice, and it is a very powerful tool under the GDPR. If you have a consent, you can move data across borders and all of that. Obviously, the giver can also revoke consent, but that does happen rather rarely, I have to say. But the question is exactly that you can't do the big things based on consent. You can't do big research. You can't push a human condition forward just based on consent. Assuming that you want to do a big health study and you ask people to opt in for it, you will get a certain biased sample of people who are forward-thinking, possibly younger, possibly more educated, something like that. But you need a stratified sample. You need people, men and women, old and young, various social backgrounds. So you may have to throw away a lot of the data that people who consented gave you. So consent doesn't solve everything. And the question about health is, in a way, some people would also say that nobody else knows what's good for my health. Let's just look at the COVID-19 vaccination situation right now, right? Ain't that a good example? There are people coming and telling you, okay, there's still a chance you can catch the disease if you're vaccinated, but it's so much smaller and you will be able to protect your loved ones. But people are still doing their own research. So the point is exactly that in some of these services will not make people happy, even if they will be arguably good for them. And then the question is exactly that, should we continue to stick to these consent opt-in models? But the question is that research should be able to continue, because one of the things I didn't mention about this fire emergency model is that it was relatively well explainable. The first interesting factor about houses that catch fire are that people live in them. So yes, if you are living in a house, then that house is much more liable to catch fire, which is very explainable. It's really explainable AI, but yes, we knew that before. And there are some other things. There were some non-trivial things, like when it's raining or the temperatures drop and people start heating their houses, and then accidents happen more probably. And that's already relevant, but you don't really need to go and do targeted interventions based on people living in a house and it's getting colder in the fall and people are putting on their stuffs. This is like, the target group you should be targeting. You can just go door by door and say that we are targeting everybody who has where you're living in and there's a wooden stove, or we know that your heating system is like that. So we're going to everybody. You're not targeting individually. And that also creates interesting options, because if you paid attention to what Google is doing with their advertising targeting recently, then their FLOC system basically does a similar trick. They say that you can target only a group of people, but you can't target individually anymore. And that is creating the power shift in advertising. Instead of being able to target the individual, you can only target the group. And it looks good for privacy, actually, but also it has a different side, which is that by building these new advertising systems, all the big companies like Apple, Google, others are creating their sort of walled gardens of advertising again, because advertising used to be a big open market, but now we have Safari, Brave, Google, all of these browsers which have a lot of tracking preventions. And it seems to be that the one losing out on most of this is just Facebook, but we'll see how that pans out. But again, it comes to the same idea of interventions. We used to be targeted individually, and that was a very targeted intervention. That turned out to be not very legal according to certain regulations on Earth. So now let's see if we can blanket target people, and let's see how that will change the whole advertising economy. Interesting times ahead. Privacy technology is being deployed. Facebook is hiring hundreds of privacy engineers, I'm being told. Hundreds. Even like I've lost some of my people to the big companies in the US, so that I know that this is a growing topic. And people, if you're listening to this, consider researching privacy technologies, because privacy engineers are hot on the job market right now.
Yeah, I wonder on the blanket approach, defining the group. If you have a lot more data points for defining the group, you can effectively define a group with the same individual characteristics as the individual you're targeting. So, it's less of a blanket. It might be more a swatch.
Yes, yes. Sort of a Band-Aid.
A Band-Aid, right?
Precisely. And that's the thing. There has been research on, for example, on Facebook. Facebook also, the filtering goals, if you want to target somebody on Facebook, then the filtering controls that they were available allowed you to go pretty granular, basically identify individual people if you knew what was very unique combination of socioeconomical attributes. So the same problem exists here. The blanket might be a Band-Aid.
Yeah, and honestly, the blanket might actually make the targeting more intrusive and more effective. Because from a data perspective, if you're able to collect, basically you're running probabilities, right? So it's actually more efficient to run probabilities with a whole host of characteristics from a group, and particularly if you can identify that the group tends to act in a certain way. Well, that targeting can be much more effective. To know that, in many ways, it's almost like just doing the analysis at a different layer.
Yes,
right?
there's a whole currently, well, obviously there's environmentalism right now, and there's this term called greenwashing, which is claiming that something is environmentally great if in fact it might not be. For example, an electric car, a Tesla running in Estonia versus running in Norway, where most of the electricity is hydro, is a totally different thing when it comes to environmentalism. So there's greenwashing.
Privacy washing?
Privacy washing. I was going to get to that.
Exactly. Oh, darn it. That was Dan's. I just was taking Dan's. Lead.
No,
you made it too easy for me. I thought I was
exactly. I was like leading you into this very well. The point is that there's quite a lot of privacy washing around, where folks are saying that in order to improve your privacy, we're deploying this new system. But the question is, what's the actual impact? What can you actually derive after you've built this system? What are the capabilities? What are the new monitoring or surveillance systems that are built as a byproduct? And this is not always immediately understood. In the privacy enhancing technologies course that I teach at the University of Tartu, the first lecture we always start with, we take a new innovation that they either take some of mine that I found from newspapers, or they find one of their own, and they analyze it with regard to the explicit and implicit features. So one thing is that you'll read the press release. This new system will allow us to blah, blah, blah. It's totally anonymous. And then I ask them to analyze them with what are the possible additional use cases or the impacts that the press release is omitting. So what would you be able to do if you have built this kind of infrastructure? And that's what in the first lecture, I try to get the students to think in these terms. And then they are taking the technologies in the follow-up lectures in a lot different way. They start thinking about, okay, if I deploy this, then I will be able to reduce data leakage in this kind of a system. So that's a sort of a alignment lecture. And indeed, privacy washing and greenwashing, I think, are very similar. Privacy and environmentalism, yeah, you can fight for them using similar arguments. Just, use less data, use less electricity. Same thing.
Shifting gears a little bit to digital identity, maybe we'll just wrap it up on there. So, what are we evolving to in terms of digital identity, and how do you look at the solutions that you're developing or hope to develop around it?
Very interesting. That's a great question, and very, very relevant right now, given that Apple right now is iOS 15 has the ability to have driver's licenses in certain wallets, maybe also ID cards. The whole wallet-based digital identity is really one potential future solution. In Europe, there is a new regulation for digital identity coming. The current draft also speaks a lot about wallets. So the situation is that the Estonian model I explained before is about I prove to the government that I am this person with this personal code, and thus I shall get access to certain services. The wallet approach instead is a sort of a digital version of a paper world. You have a wallet in your pocket, you take out the credential, you take out a paper saying that you are receiving certain pensions, for example. Then the wallet idea goes and implements this exact pattern in the digital world. And now the question is how we will implement it in technology. We'll be using the secure elements in Androids and iPhones. Will we be using some clever kinds of cryptography, like threshold cryptography, like we're doing with Smart ID? Split key is how Cybernetica calls the product. Will we be using nothing? Will we just have the data on our phones for copying? And that might actually happen because, COVID-19 immunity certificates, which tell you how many times you've been vaccinated, Europe, in a flash of collaboration, managed actually to standardize those. And you can basically go with an Estonian certificate to UK or France, and they can validate it. And it works. Actually, it works. Wonderful, but it does. But the point is also that the system is such that these can't be revoked. And the other interesting aspect is these can be cloned really easily. So obviously, if you have a pension certificate credential, then I shouldn't be able to clone it and claim it's mine. So one of the interesting challenges about the whole wallet revolution that's coming, both in the US and Europe, and possibly also in other territories, is going to be, how are we doing enrollment and onboarding? How trustworthy will this be? What will be the level of assurance that the document being shown is actually mine? I don't know how it is in the US, but in Estonia and some places where I go and they actually check my immunity certificate these days, they don't ask me for my document, meaning that the name I have on that certificate could be anyone's. Well, obviously you can differentiate between like boys' names and girls' names, but the point still is that how do you check that a credential actually belongs to the person presenting it? And that's going to be interesting. And there, again, the Estonian model works, but it has some other, let's say, some people would say features like it's quite online. The Estonian ID system means that the query is made to a revocation list, for example, meaning that there is an online component. You can't do all the identity proofs in Estonian digital ID in an offline fashion. In this wallet system, you might be able to. And now there's a question of whether we will deploy more cool cryptography like attribute-based credentials or zero knowledge to prove that I am older than 18.
So this has been the longest podcast taping that we've had, but yet it still feels like the time went by really quickly. Dan, it was so great to have you on the podcast and to get your perspective on so many things.
Thank you very much, Eric, for having me. Really, I loved the back and forth. I loved how you came up with privacy washing in a sub-second. It's always good to have these discussions where we understand each other. Thank you so much for this.